Welcome to the review session. I'd like to talk about some problems of the sensitivity analysis in this video. So here's the problem descriptions. The Pluto Auto Company makes two models of their GP sports car, a regular model and a turbo model. The only difference between two cars is their engines. All the rest of parts for either car cost $10,000. The GP regular car sells for $15,000 and GP turbo car sells for $17,000. The company currently has 30 regular engines and 25 turbo engines in stock, and Pluto can purchase additional regular engines for $2,000 and additional turbo engines for $3,400. The factory line can assemble a total of 100 cars this month, and Pluto already has an order of 50 turbo models which must be filled. Given the formulations in the following slides and the Excel output, we're going to answer the following independent questions. First question, here is formulation. This problem has the four decision variables. R is number of regular models to assemble. T is number of turbo models to assemble. RE is number of additional regular engines. TE is number of additional turbo engines. The goal of this problem is to maximize the profit. Here, 5,000 and 7,000 are net profit when we sell one regular model and turbo model. Cost of regular engines and turbo engines are $2,000 and $3,400. We also have four constraints. First constraint is number of regular model is less than regular engines in stock plus additional regular engines we're going to purchase. Second constraint is about turbo model and is same as the first constraint. Third constraint is saying that a total number of models should be less than or equal to 100 because of their capacity. But turbo model will be made least 50. Of course, all the decision variables RE, and TE are all non-negative. Here's first problem. How much will total profit change if factory line becomes more efficient and can assemble 10 more cars this month? So when you see those questions, so we know that this is about my right-hand side of my capacity. The right-hand side of my capacity constraint is increased by 10. It becomes 110. Then I said, this is about the range of feasibility. Okay, so we have to take a look at the allowable increase, allowable decrease of my capacity. So first thing to do is to check whether the change is within the range. Okay, which increased by 10, and 10 is less than or equal to my allowable increase, which is the infinity according to the sensitivity report. We know that this is within a range. And the second thing to do, check whether this constraint is binding or not. So since we know that shadow price of capacity constraint is 3,600, which is not zero, meaning that this constraint is binding at the optimal solution. Now, new profit can be computed with this formula. So our profit is going to be changed as much shadow price multiplied by change of unit. Okay, the profit is increased by $36,000. Here is the second problem. If only 40 previous orders for turbo and turbo model had to be filled, how much would total profit change? So this is about my right-hand side of my T order constraint, and the right-hand side is decreased by 10. Then I say, this is range of the feasibility of my T order constraint. Let's take a look at the sensitivity reports, and in the constraint the table you can find the relevant information to solve this problem. Let's check whether this change is within the range. Because 10 is less than or equal to my allowable decrease, so we know that this is within a range. And if you take a look at the shadow price is 0, meaning that this constraint is not binding at my optimal solution. So therefore, my conclusion is profit is not going to be changed. Okay, now Pluto is considering increasing the selling price for regular cars. But at minimum increased selling price, will Pluto consider changing its production plan? Okay, so if they consider increasing the selling price, that will affect to my net profit in my objective function. So in my objective function, $5,000 is net profit for selling one regular car. However, if you increase the selling price, this is going to be increased, right? So we know that this is about my range of optimality. So let's take a look at this sensitivity reports for my coefficient of R. Okay, so my coefficient of R, the allowable increase is 600, meaning that up to 600, if we change within this range, there will be your optimal solution, your optimal production plan will be stay the same. Okay. So we can say that minimum increase selling price that remains the current production plan the same, it's going to be $600. If you increase more than $600, then you have to change your production plan to maximize your profit. Next question. The competitor has offered 25 extra regular engines that are compatible with the Pluto's cars for the total price of $25,000. Should Pluto take the offer? Okay, let's consider RE stock constraint, because this is the change of my right-hand side of this constraint, and it becomes to 55 if we have 25 extra regular engines. If you take a look at the allowable increase of my RE stock, we know that 25 is larger than 20. Therefore, we can say that this is not within the range. However, what we know is that the shadow price will be valid up to 20. So let's compute anyhow how much profit can change if we have extra 20. Okay. So if we have 20 more, then because shadow price is valid up to 20, so we know that the profit is increased by $28,000, okay, which already exceed $25,000. So from this, we know that there's no reason to reject this offer. We should take this offer to increase my net profit. Okay. Last question. The Pluto's quality control inspector has just found that the flow of 5 of the 25 turbo engines on stock, which means that these 5 engines can be used. So what will the total profit be under these conditions? So if you take a look at my constraint, because 5 is not going to be available, so my right-hand side becomes to 20. So we have to thinking about what happened if my right-hand side is decreased by 5, what happened to my optimal solutions and optimal value. Let's take a look at the information about the TE stock constraint. And allowable decrease is infinity, and 5 is, of course, less than or equal to infinity. So we know that this is within the range, and since shadow price is 1400, your new profit is going to be changed by shadow price multiplied by the change of units. So if you compute this quantity, then you know that your profit is going to be decreased by $17,000 because of that flows. Great. So we have reviewed 5 sensitivity analysis problems. All those problems are very important. So please take this review and study them. Thanks.